Hello guys, welcome to our next video in the YouTube channel GIS and Google Earth Engine. So in today's video we're going to look at how we can estimate the land surface temperature, so both for the daytime as well as the nighttime. So using a particular data set from the Google Earth Engine, so we will see how we can do it. So in today's video our region of interest will be the Karnataka state. So let's import the shapefile of the Karnataka using our FAO dataset. So you just search FAO Global Administrative Unit Layer in the data search catalog, and here you will find the different data layers which are there. So all are vector layers. So we must use the second level administrative division, not the first level one. Sorry, we should use the first level administrative unit so that we can get the state boundary. The second level will be the district boundaries. So let's import the first level administrative boundary, and let's rename it as global administrative unit layer. And now I am creating a point layer. This is a shortcut in order to have your state of interest. So you, or else you can go to this FAO dataset layer, and you can search for the table schema, and here you will find the admin one name, admin o code. Everything will be there. There you have to filter it down to this particular property. One way is to do like that, or otherwise you can do by using the shortcut which I will show you now. So remember, the dataset is for the year 2014, so it's not updated after that. Please be careful if your region of interest has changed the boundaries after 2014 or 15. Make sure to use the updated one. So now I have created a geometry. So this is a shortcut one in order to have your state of interest. So just place one point at your state of interest and just name it as point for your interest. And now you can simply create a variable called ROI, region of interest, and uh, you are filtering down the global administrative layer which I have imported earlier to the boundary using the function filter bounds. So I am using the filter bounds function. It should filter it down to my point geometry. So that's it guys. My Karnataka shapefile is done. It's imported, and let's see how does it look by adding it to map. So just to cross check, map dot add layer, you can uncheck this point now. Yeah, clearly you can see my Karnataka shapefile is imported. So in order to fix your zoom level, you just click on the inspector column. Here you will get your lat long as well as the zoom level. The zoom level is 5 here, so you can still zoom down, and now you can click on here. Here you can see the zoom level is 6. So now I want to fix my zoom level. I don't want to zoom in and zoom out every time, so I'll just fix my map with the use of the function map.center object to region of interest, and I want the zoom level to be 6. So now if you click on the run, now you'll see it's automatically in my zoom level. So after this, now let's style our region of interest as usual in order to have only the out outline, and it should not get any kind of fill color. So I would specify my color to be outline color to be black, and my fill color to be transparent. So I'm using the octocode for transparent with the 8F, not 8F, 6F, 6 and 2 zeros. So this is the octocode for my transparent fill color, and you can rename it as ROI or Karnataka state, anything you can rename. Yeah, click on the run. Yeah, here you can see my shapefile is ready, and you can also specify the width if you want, where the width of the outline to be there. So for me it's okay, otherwise we can specify one more parameter here, width. So now my region of interest is ready. Now I want my temperature data set to be here. So let's search uh, global land surface temperature in the data catalog. Yeah, now you will see we have GCOM STLI dataset. This is particularly from the JAXA, available from the year 2021. And if you just come to the bands, it's a 4 kilometer is the spatial resolution for these bands, and we have three bands: the quality flag pixels as well as the bit mask band is there. So we don't want that. We want only the land surface temperature average band, which description is that it is a temperature of the land surface. Units are in the Kelvin. So remember, we need to multiply this with the scale value of 0.02 in order to have meaningful values. So you can also come to the image properties, and if you just scroll down, you have one property called satellite direction. So here you have the satellite orbit direction, like how does the orbit occur. So it the in a single day it will have two kind of bands. One is the A and another one is D. So if you can specify the satellite direction, you will get the nighttime data as well as the daytime data. Whichever you want, you can specify and you can simply import it down. So now I'm clicking on the import, and I'm renaming it as, let's say, temperature. Okay, so this is my data set. So now my region of interest is ready. I have the global land surface temperature, which has land surface temperature for both day and night. So remember, the dataset is only for the land surfaces, not for the sea surface. So in our next video, we'll see how we can estimate the sea surface temperature also. And now we are moving to the daytime temperatures. So now just you can have uh, uh, comment like it's a daytime temperature. We are estimating it down now, and we are creating a one more variable called day temperature. Simply for the short form day temp you can write, and from the temperature variable which I have imported, I am filtering it down to my region of interest with the help of function filter bounds to ROI, and I also want to filter it down to date. So I want the latest month, that is the March 2025. I want to know what's the temperature in here for the March 2025. So I'm just mentioning my date range to be 1st March to 31st March. Yeah, so now you can just simply print the daytime temperature variable in order to know how many image collections are available for our filter. For the state of Karnataka for the month of March, let's see if we have all the image collection. So here you can see we have 58 elements for a period of 30 days. So we have double than that. So you can just expand the features. Here you will find the bands. We have two bands. One is the LST average and the quality flag. So I don't want the quality flag, so you can just select the LST, that is a land surface temperature average band, and here you will see for the 1st March of 2025, this is how you can read the date in the image collection. So it's written in the inverse, like I have given the arguments in the inverse, the dates are also in the inverse. So it is the satellite image acquired at the night time for A, which is suffixed by A, and D will be suffixed by for the daytime temperature, and A is for the nighttime temperature. So for single day, you have two bands. For the day two, you have two bands. Like that, you will have different kinds of bands for the entire month. So you can see we have the ending at 29th. We don't have 30th and 31st date of satellite images because the latency of this particular product is 3 to 4 days. So here you will see 3 to 4 days, since we are in the April 1st. So it will usually take 3 to 4 days in order to update the bands. So now we want the daytime temperature only. So how we can filter it down to daytime temperature? With the use of the function again filter. So now I am filtering it down dot equals to. So let's go to our data again, and go to the image properties and select our satellite direction. Just select this property and paste it in here. I am giving the arguments that this particular property should be equal to day only, so that I will get the daytime temperature. And after all this, now you can click on the run. Now your number of collections will be reduced. Here you will see we have only 29 elements for the 29 days. All our A bands which are suffixed with the A have been removed. We have only the daytime temperature bands now. So after all doing this, you can still see we have two bands. So now let's just filter the band also with use of the function dot select. So again, if you don't know what's the band name, you always go to the dataset catalog and just copy the band name and paste it in here. So I'm selecting this band. Now if you click on the run, my image collection, I have 29 elements. That means 29 images are there with only single band, and a daytime temperature is there. So this is cool. My data set is ready. Now I want the average mean temperature for the month of March. So just give mean. That's it. My mean temperature is ready for the month of May. Now the last thing I have to do is clip it down to region of interest. So everything is done, guys. Our daytime temperature data set is ready. We need to add this to layer. Before that, we need to, I forgot to multiply it. So before calculating the mean, after calculating the mean, you just multiply it with the scale value of 0.02. So in order to reduce the dataset available storage, the uh, providers usually give them in the integer value, so we need them in the floating value. So here you will see 0 to 65,000 kelvins cannot be possible, so it has to multiply it by 0.02 in order to have the accurate values, since the units are in Kelvin. So I'm just multiplying it by 0.02. That's our scale value. Now our daytime temperature is ready. Now you just add it to map with the help of the function map.add layer, uh, day temperature. Okay, now click on the run. Our two layers are loading. One is the Karnataka state boundary and another one is our daytime temperature. So let's see how does it look. So you will find a grayscale image. You find nothing. This is not a good visualization. So we will alter this. Don't worry. So if you can just stretch the values to 100%, here you will find 300 to 323 is the range of the average land surface temperature for the state of Karnataka. So now you can just go to our dataset and you can just click on this button, so that you will come to this tab, and you have a again you will get the description of the dataset. Whatever the bands image properties will be opened in a separate tab. That's it, there is no difference. So here the Earth Engine provides a JavaScript code snippet for the newcomers, for the beginners. So here, from here you can copy the palette, like the colors which are good for the visualization purpose. So I have just copied it down and I'm pasting it in here. Sorry, I didn't copy it. So you can just copy the visualization variable and select copy and paste it in here. So like I have told, this is the hexacode octacode for the fill color for making it transparent. These are all the octacodes or hexacodes for uh, the colors. So it will have the minimum as well as the maximum value. For our range, the minimum will be 300 and maximum will be 325. And we have the palette, we have the band to visualize, and you can just remove this band because we have already selected the band. So now you can just copy this variable and paste it in here. So this will define our visualization parameters which are required for visualizing the land surface day temperature. So we just rename this layer as daytime temperature. So now if you click on the run, you will get a beautiful layer rendered with the colors which we have provided. So yeah, clearly you can see our Western Ghats region has a low temperature because of high vegetation in there, and these are all the Bidar regions, and the north of Karnataka, relatively dry regions, are all very much hot. So if you can see our palette, it ranges from blue to green, yellow, and red. So wherever you can see the red color, it's a highly high temperature is seen during the month of March. So if you can just go to the inspector column and click on the inspector pixels, so you find the land surface temperature at this region in the for the month of March was 321 Kelvin. So it's quite high. If you click on the blue colored regions near the vegetation regions in the Western Ghats, the temperature is relatively low, amounts to 300 kelvins or something. So this is how you can visualize the temperature anomalies for your state or any region. So it's preferable to take the large data set, since large region of interest, since it's a 5000 kilometer, um, nearly 4.5 kilometer resolution is there. So it's useful to take so usually all the climate data will have this kind of resolution only. So the resolutions will be still low because most of them will be gridded data sets where they have integrated the ground stations with the satellite data. So the resolution will be usually low only. So now we can have the day surface temperature is ready. Now we'll have the similar to that. We'll see how the nighttime temperature varies for the same region. So you can just copy this variable daytime, and you create one more variable called nighttime. So just copy and paste it in here. So if you want, you can again comment this. So it's a good practice to always comment down whatever you are writing, because as soon as you write more line of codes, you will forget what I have written in the upper section. So if you comment it down what I have done in the below columns, it will be a good practice. So I am commenting it down to nighttime temperature, and now we can change our variable to nighttime temperature. So everything will be same. We have filtered our temperature dataset, global land surface temperature dataset, to our boundary using the filter bounds function, and we have also filtered it to date for the same month. Again, we have the March, and but the property satellite direction should be changed this time to A. So remember, we had two orbit directions for the satellite, daytime and nighttime, where A stands for nighttime and D stands for daytime. So only this thing you have to change, and everything remains, the rest will remains the same. So you just add this to map with the help of function map.addLayer, and we have our variable night temperature, and we have our visualization parameters also specified. So you can just copy this and paste it in here. And you can rename it as nighttime temperature for this layer. So that's it, guys. Just run it. We'll see how both looks, and how both gonna differ during the daytime and nighttime. We'll see what's the science behind. So we need to extract the values. We need to change the minimum and maximum values. It's from 289 to 302. Since the minimum maximum values are more variables, you just give the palette, and you'll specify the visualization in the map.addLayer function itself. So you define the palette. That's it. So here for our minimum value was 300 and maximum value was 325. This was our daytime temperature and palette was palette itself, because we have defined the palette here. So you can just specify in here, and the code will take by itself. So here also will change the minimum and maximum values. So minimum was, I think, 289. So let's just cross check. Yeah, 289 to 302. 289 comma max to 303, and our palette will be palette itself. So now let's give the run. Yeah, so here you can clearly see, guys, the nighttime temperature and the daytime temperature. You can feel the differences. So the coastal areas are experiencing uh, a heavy high temperature during the night time, mainly because of the sea breeze. And in the night times also, here you can see uh, in the hotter regions, in the night time there are low temperatures. So this is the difference between daytime as well as nighttime temperature. So I hope, guys, you have understood how you can explore the temperature anomalies across the daytime, nighttime, across all the months, for even a day, and for the satellite directions you can explore in the Google Earth engine. So I hope you have understood how you can do this in the for your own region. So one more thing to add is that if you open the dataset, sorry, say there was some internet problem. So if you just open the dataset, you can see the dataset is available from only 2021. So what if you want the data of the temperature beyond 2021? So how you can get that? So you can just search uh, sheets in here. Yeah, here you have from 1983 to 2016, so it's not updated. So only till 2016 you have this data set from 1983. So the resolution is more or less same. That was 4.5 kilometer. This one is 5.5 kilometer. So it have the minimum temperature as well as the maximum temperature in terms of degree Celsius. So this is one of the useful data set which you can use. The description also given, that is the lowest temperature according to 2 meter above the ground surface for 24-hour period. So one disadvantage is that it doesn't give you the nighttime temperature, so it does only give you the daytime temperature. So for 24 hours it will be uh, an average, so you don't have a separation between the daytime as well as the nighttime. So for 24-hour period the temperature is recorded. So the remember also the units in degree Celsius. So you don't need to multiply with any of the conversion factors, and you have a large date range from 1983 to present. So I hope this data set was also useful. So I hope you have enjoyed the video. Thank you for watching, guys. If you have any kind of queries, you can always post in the comment section. Thank you. Good luck.